So if you want to find the area of a triangle, it's vertices x1, y1, x2, y2. So you have some triangle hanging out there in the xy plane, and you want to find the area of this triangle. All you have to do is use this trick, which comes out of, we'll talk, I think in chapter 10 we talked about the cross product, but really it is the cross product that you're finding, but they don't tell you that yet, okay? And what it looks like is this x1, you put x1 here, you put y1 there, you put a 1 here, okay? And then you put an x2 here, and you put a y2 here, and you put a 1 here, and you put an x3 here, and a y3 here, and you put a 1 here, and then you take the, so it's kind of like a double bar here, because the area always has to be a positive number, right? Okay? And so basically what you're finding here is the area of a parallelogram, right? If you found this quantity right here, which is the discriminant, right? So if you found this discriminant, you come up with some number. That number may be either negative or positive, okay? So if you found this discriminant, that would represent the area of, if I were to continue this and make like a parallelogram out of it, or a rectangle or something like that, this quantity here would represent the area of that, except it might be negative. So after you take 1/2 of it, then you take the absolute value, okay? And it just comes out of the cross product, which we'll learn about more in chapter, I think it's in chapter 10, okay? And so, for example, if I had find the area of a triangle with vertices 1, -1, 1, -1, 2, 3, 2, 3, and 5, -3. 5, -3. You just plug those numbers into this formula, okay? So I'm going to do that right here. I take 1/2 of, and I put a bar here, 1/2 of 1, -1, 2, 3, and 5, -3 goes here, and then you go 1, 1, 1. And then you just find the value of that discriminant, okay? Determinant, sorry. Discriminant is the thing inside the discriminant. I always get those confused. Discriminant is the thing you use in quadratic formula. You know, the b squared minus 4ac. Determinant is this thing, okay? I always get those words mixed up. So anyway, if I evaluate this, it's going to be 1/2 times the absolute value of, well, it's going to be 1 times what? 1 times what? Hello. If I cross out this row and this column, what am I left with? 3. 3 minus 3, right? 3 minus 3. Everyone with me there?
Yep.
We're just evaluating this discriminant. Like you cross out this column, this row, and you're left with this discriminant right there. Determinant, sorry. Determinant. Okay? Minus, right? Then it goes minus, but it's -1, so it'll be minus, right? Minus 1 times this determinant, 2, 1, 5, 1. So 2, 1, 5, 1 gives you 2 minus 5. I'm just going to do it, right? And then plus, right? 1 times, cross out this and this, 2 -3 is -6 minus 15, right? -6 minus 15. And then you do this, and then you do this. And then so you get 1/2. It doesn't really matter where you put the absolute value thing. I could have put it, take the absolute value of this and then multiply by 1/2, or multiply by 1/2 and then take the absolute value. It doesn't matter, okay? So I have 1/2. 3 plus 3 makes 6, right? 1/2 of the absolute value of 6 plus 1 times -3, right? Which is -3 plus 1 times -21 minus 21. Yes? What's the absolute value of this? 6 minus 3 is +3. Minus 21 makes -18. So you take 1/2. Absolute value of -18, which is equal to 1/2 of 18, which is 9. That's the answer, okay? So the area of this particular triangle with those vertices is 9. And that does come out of the cross product, but right now all you have to know is how to apply it. Easy enough? Easy enough? Okay? So what kind of a corollary to that, corollary means something that follows from that, okay, is that, where'd my stuff go? I think, there it went, okay. A corollary to that is that collinear points. If 3 points are collinear, and collinear, don't ask me why, it has 2 L's in it, okay? Then, what would be the area of a triangle? Then, let's just do this. Then 1/2, that's the value of 1/2 times x1, y1, 1, x2, y2, 1, x3, whoops, messed up. X3, y3, 1. What would that be equal to? 0. Why, Connor? That's correct.
It's a straight line.
Right. If points are collinear, right? Well, here's 1 point, here's 1 point, here's 1 point, right? Then if they're collinear, meaning like that, that means that they couldn't make a triangle, right? And the area of that triangle would be 0, okay? So if 3 points are collinear, then, okay, this quantity equals 0, okay? And so they'll ask you, are these 3 points collinear? And you say yes, no, maybe. Let's just do one, okay? Are 0, 1, 4, 4, and 8, 7 collinear? Yes. Well, how do you figure that out so quick?
Because it goes up by a set.
Yeah, it's another way to just look at it, right? This is going up by 4, this is going up by 3, so they have the same slope, so they'd have to be on the same line. But just to prove, you understand what Connor said, right? Because the slope between these points and the slope between these two points, but they could have the same, no, they couldn't be on the same, if these are on the same line, well, yeah, you have to check, yeah, if they're all going up, over and up by the same amount, they'd be on the same line. But let's just check to make sure that's true this way. 1/2 times x1 is 0, y1 is 1, 4, 4, 8, 7, 1, 1, 1. So the determinant of this, 1/2 times this is going to be 0, right? It's going to be 0 times something, which doesn't matter, right? Minus 1 times 4, 1, minus 8, right? Minus 4, minus 8, plus 1 times 28, minus 32. 28 minus 32. So they might ask you to prove that it's collinear. So that's equal to 1/2 of, that's a value of 0, minus 1 times -8 makes plus, -4 makes plus 4. 28 minus 32 is negative 4, right? Minus 4, and that you take 1/2 times the absolute value of 0 is 0, and you get this equals 0. So yes, they're collinear. Is that hard? Okay, that's the end. Holy cow. Is that the shortest I've ever taught? Right.